Great, Nicole. I got your email, by the way. So you did as much as you need to do for right now on that assignment, even though you couldn't get the VPN working. Got close enough for now. Okay. I'm gonna log into my notes on a different computer here. Let me turn up. Now I'll leave that virtual back. Is the virtual background distracting? I know it doesn't work that well today because I don't have a good background. Let me change that because it's distracting to me. So. Alrighty. Hopefully I have the grading done of the exams by this evening. Still grading them, still looking through them. Okay, talked a lot about wireless LANs in the previous class. Talk a little bit more about LANs today, and then we'll get into WANs, wide area networks. I wanted to point out in LANs a few other elements of control, such as LAN segmentation and what segmenting is. A LAN segment. A segment is different from a subnet. A LAN segment is at layer 2. Subnets at layer 3. I've specified that several times, but I just want to make sure you guys understand that. So we were, let's see, where we about. Got too many keyboards in front of me. Okay, let me reiterate a couple things on this slide here with respect to networking. The original Ethernet specification, and actually the current Ethernet specification, is still a bus-style Ethernet. And when I say bus, you can literally think about that kind of like a school bus driving around a neighborhood picking kids up. From the neighborhood, the bus follows a specific route and stops at one location and then drives on and stops at the next location. That's kind of like how Ethernet is working, in that your frames originally, when the Ethernet was designed like this, think about your frames hopping on a bus here, then that bus driving to the next intersection, and then more frames possibly hopped on that bus. Maybe some frames hopped off the bus. Maybe a school bus isn't a good analogy. An analogy of a city bus might be better. People getting on and off the bus in a particular intersection. Now, the advantages, the disadvantages of this kind of technology, this physical layout, is not a good layout for the reasons I stated yesterday. If somebody disconnects from here, it essentially destroys that intersection, and you end up killing the network. Also, there is no central controller device, which meant that since there isn't a central controller, you lose some control physically and as a network manager. You can't, if you want to perform any sort of control, you would have to log into and have control of each of the individual workstations or nodes on this LAN. We want higher level, hierarchical control. So in a star network, that works much better. Just keep in mind that Ethernet still is a star topology still a bus network logically in the way that it works. It's still potentially causing there's still potentially collisions that occur, as in the case of hubs, where the message is electrically reproduced along all of the ports. This also does occur in switches the first time a frame is transmitted from a node. When a node, excuse me, I'm a little hoarse. When a node first turns on, it starts sending frame out. The switch doesn't know and doesn't care who's connected to it. It has to get at least one frame from a certain node on a certain port before it can make a notation. Okay, you're from where? Okay, your source IP address number so-and-so. Let me write that down. And remember that frames with your MAC address, excuse me, not IP, MAC address, are coming on port 1. So let me make a note of that and put that in that table. So switches have to operate as hubs initially just to learn the data. And that also makes them downward compatible. One good thing about Ethernet, and that's always been kind of an edict, is that Ethernet is downward compatible with really, really old hardware. As long as the physical specifications are there, Cat5 or BNC, as long as you can physically connect that device to your Ethernet network, even if your switch is a 10 gigabit network, it probably also will step down to 1 gigabit, 100 megabit, 10 megabit, even 10 megabit half duplex, which is the older original Ethernet. So switches work like this. Keep that in mind, but just keep in mind, although this physically is a star topology, it's still logically a bus topology, because potentially that message for computer C, if the switch doesn't know where computer or node C is yet, it's still going to transmit those frames to every single node that is physically connected to it, and these other nodes are still going to get it. They're going to ignore it. They'll probably report back to the switch, that's not me, I'm not here. But this node, node C, will receive the message and go, oh, here I am, I'm on port 3 here. Then the switch will make a notation of that, and then it won't send those frames out to all the other B, D, and E at the same time. So switches take a few seconds, sometimes a few minutes, to start properly operating as physically a star, to where they're segmenting the traffic. That's not the right word. They're partitioning. Partitioning is the right word. Partitioning the frames to only go where it's pretty sure it should go. Now, switches aren't perfect. They're fallible, and that's because perhaps this node here, let's say this person that's sitting in this office on node A, he changes his computer out and he plugs in. Presumably if this was an office where this computer was sitting, there's a port on the wall that he's physically connected to if it's a desktop computer. If he disconnects that computer, connects another one up, it's going to have a different data link layer MAC address. So a new MAC address is going to come in from that port and hit the switch, and it's going to go, I don't know who you are. Who are you? Are you a different guy? It's still going to keep that old data for a little while, but it's going to take that new data, write that into the table also. So because sometimes, not very often on wired networks, but on wired networks, things don't change very often, but when they do, it takes a little off of the switch to keep up. Now on Wi-Fi, on wireless networking, change happens all the time. And so switches and Wi-Fi, switching in Wi-Fi sometimes takes a long time, and there's a lot of overhead involved with Wi-Fi switching. And this is another good reason why Wi-Fi is not necessarily the most it's certainly not the most secure, but it's also very inefficient because, first of all, everything has to be encrypted coming out of Wi-Fi from one computer to another. And there's a lot of back and forth. There's literally, for every one frame in Wi-Fi, there's 3 other frames that go back and forth, 3 to 4 other frames that go back and forth to verify that data. So Wi-Fi is inefficient because of that. Wi-Fi Ethernet is. Okay, so let's see. Wired Ethernet switched operation. We call them switches. Switches learn the MAC addresses associated with physical port. If not found, frames are broadcasted to all devices just like a hub initially. A table, which now your ARP table, I think I've showed you that before in class, how you can drop out to a command line and type in ARP space -A. I'm not going to do it again right now, just in the interest of time. There is a table in there which is similar to this table. It's a MAC address to IP address table. This is a MAC address to physical port table. This is inside the switch. If you could log into the switch and manage it, and some switches are managed. Some switches are called managed, where they actually are running a layer 3, and you can optionally give them an IP address and log into them. So not only is it connecting these other devices, but you can log into it with an IP address that you either assign it or assigns itself. And you can look at nice, pretty GUI web pages that give you this kind of information. Those switches cost more. In fact, if you were to go out and Google for the cost of managed switches, let's just look for a cheap 48-port switch. Oh, I'm sorry. Keep typing on the wrong keyboard. Let's see how cheap we can get a 48-port non-managed switch for. It might be kind of hard to find a 48-port non-managed. Let's look for a 24-port non-managed switch. 48-port switches now are almost all managed. Switch. Close enough. Okay, there we go. That's pretty darn cheap. That's probably about as cheap as you will find a semi-business grade switch. TP-Link is a very low-end manufacturer. It's still fairly good equipment, but they're kind of like the Volkswagen or the, maybe not Volkswagen, maybe that's not a good analogy, maybe the Kia of the networking world. They make stuff that's functional, but it's not, you know, their website's not great. They don't have good customer service. It's primarily a Chinese company. But we call this is a metal switch, by the way, and we call that a metal switch because it's literally metal. We do not ever use plastic switches or consumer grade switches in business applications. You can probably find a 24-port plastic switch even cheaper, but the chances of it operating for more than 1 year are not very high. Also, it probably can't handle the traffic. It might be able to handle the traffic if 5 or 6 of these 24 ports is busy at one time, but not all 24. So anyway, that's pretty cheap, 60 bucks. Now, if I add into the mix that I need to buy a managed 24-port switch. In fact, TP-Link also makes managed 24-port switches. That's probably not one. Let's just look for that same brand. Oh gosh, I keep typing on that wrong keyboard. I'm gonna disconnect that keyboard and type it in on plug it in over here. TP-Link managed switch. So it goes up. That's pretty cheap. I doubt that one's a managed version. But they're going to be at least 50% more. And that's because there's basically additional programming in them. They have a layer 3. Normally switches don't have a layer 3, it's just layer 1 and 2. Another term, by the way, for a managed switch is called a layer 3 switch. So we could have also Googled for that. Layer 3 switch. And you can read up and look at the difference between layer 3 and layer 2 switching. Layer 3 switching gives us better control up here at the IP layer. A lot of layer 3 switches let us put in firewall rules, excuse me, and partition out our traffic so that we can literally create two LANs, two separate LANs at layer 2 with one physical device. It's easier and cheaper typically to manage fewer pieces of hardware. We want to try to reduce the amount of hardware that we're using because, as I said before, hardware is one of the most common things to fail. Okay, don't worry about that kind of switching. I had mentioned we don't care about that. Let's skip that. I've talked about that already. I've talked about wireless Ethernet already. Wi-Fi. I've talked about omnidirectional and unidirectional or bidirectional antennas. If you want me to, I will show you. Let me go ahead and show you real quick a couple of differences between the antennas. Now, if you're lucky enough, this is called a Yagi antenna, by the way, and that's a unidirectional. If you're lucky enough, or if you bought and paid a little bit more for a gateway device that has detachable antennas, or actually external antennas. A lot of the gateways that you buy for your homes don't have external antennas, or they don't have ports, or the antennas that are on them are they're built in. There's no way to unscrew them. But if you wanted to better control the radio waves, you don't have a lot of control. You have better control. There's a zone of radio frequencies called the Fresnel zone. It's actually spelled Fresnel. I keep typing on the wrong keyboard. Put that keyboard to the side so I'm not tempted to type on it. Looks like Fresnel zone, but it's called the Fresnel zone of radio waves. The Fresnel zone is basically the zone at which the radio waves are the strongest with particular antennas. So some antennas are omnidirectional, where the Fresnel zone is very strong and very wide, in that, let's say you have a tall antenna like this. A Fresnel zone literally measures not just how far out the wave goes, but how far up and down the frequencies are. And usually the higher the dB level, the decibel level, if you're looking at routers, and this might be something that you would be curious about, the little home routers and the little home access points probably don't list this, but if you look specifically for access points, wireless access points at Amazon.com, for example, and you're comparing them, specifically Google for, or look on Amazon for outdoor wireless access points. And one of the measurements on there will be dB, stands for decibels, the dB power. If that number is really low, like 3 to 5 dB, that means the Fresnel zone is a very wide zone and it's not very unidirectional, it's relatively omnidirectional. But if you want to use an outdoor antenna that is powerful and you can point those radio waves in a narrow column, you can't point them literally like a laser beam, but you can point them in about a 60 to 90 degree direction. They have some antennas called vector antennas, which are a little bit narrower than that. They use those for cell services. You can get the frequency, the signal basically to travel further. Okay, so not going to ask about Fresnel zone on the test or dB levels, but this is going to come up probably more and more and more now, especially for you guys if you get hired to a company where you're tasked with providing wireless access service to your campus. And I'm not talking about a school campus, I'm talking about an office campus where people are outside or they're in the field, and you need to improve the Wi-Fi, not just to laptops, but you need to possibly shoot Wi-Fi from building to building because it's expensive to put cabling down. Okay, so wireless. Now, one thing to remember and realize about wireless, it can go through some things, but one thing that wireless cannot go through is the earth. So we can't use wireless to send wires wireless signals directly down into the earth, just like satellite. We can't use satellite to send signals down into the earth. Now, we don't typically use satellite for LANs at all. We use satellite for WAN. How many people in here that you know of have a gateway at home that has external antennas on it? You can go look now. You can get I'll wait. No, I'm not going to wait. I'm just kidding. If it's a lower end wireless access point, or it was provided by your internet provider, like Xfinity or AT&T, probably doesn't have external antennas. How about your laptops? You know, not external, but there's an antenna in your laptop. If you were to break the laptop open or pop the top off or the bottom off of the monitor part of the laptop, don't do that right now. You'll see within there some cellophane tape that goes around, or some, not cellophane, aluminum or some foil tape that goes around the edges of your monitor, your screen, your LED or your LCD screen. That's your antenna. Okay, now the correct term is WAP, wireless access point. The generic term access point literally just means any connecting point at which we can get into a network, but we stopped using WAP a long time ago because I guess it's hard to say or whatever, so we just say access point. Now keep this in mind, I mentioned this yesterday, an access point is not a router. It's not working at layer 3, it's working at layer 2 only. Once you authenticate to an access point, that SSID, and I'm going to talk about this next, different ways of authentication. Once you authenticate to wireless, go down to, we've already talked about that. Once you authenticate to wireless, you still got to get a DHCP address from some other server probably on the network. And the wireless access point is just going to give you the physical and data link connection. It has to connect to something else, typically by a wire. It has to connect to something else to then send that traffic at layer 3 somewhere else. Usually it's attached to a switch or a router or a gateway that's at your home or your business, which then connects to the internet. And that's an access point. If you have a device at home which is providing Wi-Fi and it's got Ethernet ports on it, and it does DHCP and it does firewalling and other things, that's not an AP. Don't call it an AP. Now, some of these devices that provide access point services that look like smoke detectors that you stick on the ceiling, they have different modes. There's what they call gateway mode, which works just like your Comcast gateway or Xfinity gateway, where it's providing NAT translation and DHCP and your connection to the internet. Or you can put it in access point mode. And then there's also another thing called bridge mode, and I'll talk about bridge mode in a minute. Here are some different protocols for wireless encryption or wireless security. Because it's wireless, we don't have any physical security. The physical security for wired is you don't put ports on the wall for people to jack into. Then they can't get into your wired network, but anybody can get into a wireless network simply by driving up, if your signal is strong enough, parking in your driveway or sitting out in front of your house. And keep in mind that this is called war driving, by the way, that even if your signal is weak on your Wi-Fi and you can't pick it up, other people possibly can, because maybe they're driving around with a Yagi style or a unidirectional antenna, which you can make or you can purchase. There are plans on the internet on how to make an antenna out of a Pringles can. How to make a Wi-Fi antenna out of a Pringles can. Now, why would you make an antenna out of a Pringles can? Because what you're trying to do is take a regular antenna that you would connect to your laptop or whatever that you're driving around with, and you want to basically turn that into a unidirectional antenna or a directional antenna where you can point it. So people literally take cans, maybe it's a Pringles can, maybe it's a coffee can, I don't know what it is, but the can, the metal, it's got to be a metal can, helps to direct those radio waves in a specific direction. And you can get much further distances with the so-called Pringle can. Oh gosh, I'm hungry now for Pringles. Don't eat them very often, but anybody else have a Pringle fetish, or is that just me? Love Pringles. Okay, so encryption, wired equivalency privacy, and again, in a lot of cases with wireless access points, they're downward compatible. You can choose no encryption. You can choose open encryption, and you can allow people to connect into your access points without any authentication at all. There are reasons why you would want to do that. Like if you're a hotel, for example, and you want your guests to be able to log in without stopping there, because there's not actually a lot of control at that point. You can control things by forcing them to what's called a landing page or a captured portal, where even if they try to go to google.com, they get forced to this Choice Hotels or Hilton hotel page, where you have to answer a couple of questions like what room are you in and what's your last name, or maybe even put in a credit card and pay for it. Has anybody stayed in a hotel? Your daughter loves Pringles. Okay, that's good to know too. Anybody ever stayed in a hotel where they charged for networking? Or maybe they gave you very basic networking, like 1 megabit per second, super slow networking. Almost all the hotels in Las Vegas, because it's fairly cheap to stay in Las Vegas, but the hotels, the way they make their money is they charge you resort fees and internet fees and $5 for a bottle of water and stuff like that. That's how they make their money. So they have basically 2 ways to connect in, but they don't use any protocol. It's open protocol. Now, when you're using open networking, I don't recommend it at all, because usually there's no encryption with that, meaning the data coming into and going out of your computer is not encrypted. Unlike Ethernet, which can partition out that physical data, I can run specialized software on my computer and pick up your wireless frames, which might have passwords in it, might have sensitive data in it. So I recommend don't ever use networking where it's open. Or if you do use it where it's open, make sure that every website you visit is secured by HTTPS. It's a secure website. Or that you're using VPN to connect back into your home network. Or that you're using email programs that are encrypting at the application layer. So if you're encrypting up here at the application layer, it doesn't matter if the data link layer is encrypted or not, because all your application data is encrypted. So maybe somebody could pick up your packet, your frame, but it's going to look like a bunch of gobbledygook to them. Yeah, or if you're a hotel member, like I'm a member of Caesars, and I have a veteran card, and they give veterans some perks. Now, WEP, Wireless Equivalency Protocol, Wired Equivalency Protocol, It's a very simple protocol. It uses basically just a string of either 5 or 13 characters. It's real easy to hack, so don't rely on WEP. WPA came along a few years ago. Some guys figured out how to hack that within a few hours, so WPA2 came along. And WPA2 has a couple of different ways of encrypting the data. There's either TKIP or TKIP, we call it, or AES. And these are things that are usually specified by the provider of the wireless service. They usually tell you, by the way, our internet is using WPA2 with AES or TKIP, or maybe both. AES is better. And I don't need you to remember what AES stands for or TKIP stands for. Just understand that these are subclassifications of wireless encryption protocols for security. And this is happening at layer 2. So even if you were using insecure applications, and when I say insecure applications, that's anything that's not being encrypted up here at the application layer, That's okay because your data link layer will encrypt it. That doesn't happen on Ethernet, it's wired Ethernet. So that's actually good there. Now, can you hack 802.11 WPA2? Yeah, you can, but it takes a long time because the encryption is so good. As long as you use a fairly good key or pre-shared key, or what we call a secret, which you plug in, that's that password that you log in with the WPA2 with. What that key is that it actually takes that key and makes that part of an equation that's executed on your data that encrypts it. And then the private part of that key, which is a matched pair, decrypts that data on the other side. And then there's WPA2 personal and WPA2 enterprise. Let's not worry about what those are for the scope of this class. Now, that's pretty good, but it can still be hacked. Or let's say you are staying in a hotel and you're a preferred member. And because you're a preferred member, you get an email that says, hey, here's the password for today to use the Wi-Fi. Some hotels change the password daily or weekly, or they give you a code. There's nothing that might keep you from giving that code to your kids or to the guy in the hotel room next door or your buddies or whatever. Nothing to keep them from giving you that, because they don't know what hotel, they can't tell you're in your hotel room. They can sort of tell, but if you want to take your laptop down to the pool and sit there and use your Wi-Fi, you're not in your room. So they don't have a lot of control over that. So what some sites do, if they're even more paranoid about that, is they do MAC address filtering, where you have to give the provider, the network provider, the MAC address of your computer, of your host. You have to literally click over here in the down in the network information, and you have to look it up. By the way, I'm on Wi-Fi right now. Am I coming over okay? Did I get an update on the MacBook VPN? No, I'm not sure what you're talking about. Did you send me an email? I'll take a look at what email you sent. You have to literally type in the MAC address to a table that the access point references before it will pass frames for you. That's pretty secure because the chances of me being able to copy or duplicate your MAC address are very low. Even if you gave me your MAC address, if you gave me your MAC address and I tried to type it into my computer and emulate it or pretend to be that other computer, if that other laptop is already communicating with the access point, it probably will not communicate with your access point or your laptop, because it'll say, oh, I've already got a session going on. So I've got some friends, oh, so sorry, it's Friday. So sorry, I've got some friends that are very paranoid when I go over to their houses. They're physicians or they believe in conspiracy theories and all that. So when I go over and I try to get on there, well, what's your Wi-Fi? Well, what do you want to know? Well, you know, my Sprint is being slow right now. Can I use your Wi-Fi? Well, okay, give me your MAC address. And I literally have to give them my MAC address on top of a password to be able to get onto their Wi-Fi. And then they usually put it into a table that expires in 24 hours or less anyway. Now, again, you can do security. You can do open security and not use either one of those, but you have to send somebody to what's called a captured portal. Here, let me open a WordPad document so I can put these terms down, because you do need to know what this is, because these are more common for casual situations where you're staying at a hotel or you're at a convention or you're a temporary worker, and it would just be unwieldy and difficult to manage people coming in and out of your place of business, some of which need internet access, some of which don't. So this is true for a lot of hotels. Their Wi-Fi is open, and it will usually tell you, by the way, when you try to log into Wi-Fi, it'll tell you, there'll be a little asterisk by that SSID that'll indicate that's an open network. May or may not be secure. Captured portal. You try to go to google.com or netflix.com or anything, and it says, welcome to Hilton. And that's because they can control the frames. The frames are going to their access point and then to their routers, and their routers can say, well, you're not authenticated yet in an application table, not in an IP table. It's an application table somewhere. You have to be running special applications for this until you authenticate by typing in your room number or your credit card number, and we authorize you. We're not going to let that traffic go anywhere other than our beautiful website. So, and that's true like with this Xfinity Wi-Fi, by the way. If you're using Xfinity's Wi-Fi, the public Wi-Fi that's out in the field there, if you don't have an Xfinity account, you can go to all the Xfinity websites you want to, whatever.xfinity.com, but you can't go anywhere else. And of course, they're trying to sell you Wi-Fi services, or they might give you 1 hour of free internet, but it's going to be very slow, throttled. They call it throttling. We'll talk more about throttling and security with respect to hotels, because hotels, sporting events, those are the worst places to be surfing the net and doing anything that is sensitive. One hotel you stayed at limited only 2 devices be connected to the Wi-Fi with the code they gave you at check-in, since that's the amount of people I paid to check in at the hotel room. Yeah, so some of them are really strict, and that's typically because a lot of the business class hotels, they're kind of expected to give Wi-Fi for free. The business class ones are. It can't really be a money maker for them. They have to provide it just like they used to provide, and a lot of hotels still provide telephones on the desk by your bed. Does anybody actually use a telephone in a hotel? Not really. Hotels used to make money from that, but they can't really anymore because everybody's got a cell phone on them. So hotels got to dream up other ways to make money. Okay, when you're designing a wireless network, it's very different from designing a wired network. When you design a wired network, you can use a nice wiring diagram like draw.io or Visio, and you can with wireless networking, because we looked at one of those templates, but the issue is that we cannot control those radio wave ranges. So we approximate with a circle, or maybe not even a circle. It really should be a sphere. We approximate with a sphere. Those radio waves go in every direction, left, right, forward, backwards, and up and down. Now, when an entity, like a multi-story building entity, like let's pretend this is Melcher Hall again, is planning wireless networking, they have to consider, well, if I've got a wireless access point up here on the 3rd floor, it may or may not. It may penetrate a little bit of the 2nd floor. Some people on the 2nd floor may be able to pick up signals, but probably nobody on the 1st floor will be able to, because there's just too much to go through. Not just the floors, but also people and desks and furniture and other stuff that's in these occupied spaces. So when we draw our land maps, we use circles. It's really difficult to draw spheres, and spheres don't really mean too much because we don't really live in a 3D world. We don't work in a 3D world, although we do live in a 3D world. We don't work in a 3D world. In other words, if there are other people that we're doing business with or that we're interacting with in one department, we're on the same floor as them, or we can see them if we're in an open environment like that commercial where, you know, Jake from State Farm is talking and the guy in the next guy is in one cubicle over. In that open kind of environment, that's a very, very common environment. Does anybody work in an environment like that where you're in a cubicle? You can stick your head up over the cubicle. There are pros and cons to that. Having individual offices is not as effective a lot of times in terms of communications. So depending on your environment, if it's an open office environment, we have to make sure that we provide wireless access points on every floor, and then possibly multiple wireless access points on those floors. If this is a long building, for example, this is an odd L-shaped building. And also, one other point, I mentioned this the other day. Most of the commercial access points, you do have the ability to reduce the power. You can certainly increase the power, but sometimes you want to reduce the power, and that's because wireless access points can interfere with each other. Think about wireless access points like speakers on a ceiling in a particular location. Anybody been to a baseball game? Well, probably not recently, but you've been to a major sporting event, right? You've been to Reliant, you've been to the Fertitta Center, you've been to a baseball stadium. Anybody ever been to the Houston Livestock Show and Rodeo to watch a concert? The sound is terrible there at those places because your ears are picking up the sound from a speaker that's relatively close to you, but then you can also hear sound from speakers that are placed throughout the stadium. So what do you end up getting? What's that term? You get echo. Echo is basically unwanted. It might be the same signal, but it's delayed, or it comes to your ears or comes to your device at a different time. And something similar to that happens with Wi-Fi. So when we have smaller confined spaces like this, let's pretend all of these are the same brand and same model. We might need to tune those speakers. If you want to pretend like they're speakers, you might need to tune those down so they don't interfere with each other. Now, you see these 1, 6, and 11, 1, 6, 11, 1, 6, 11. There is, in this country, there's, well, in 2.4 gigahertz range, there's 11 to 14 channels. Now, your Wi-Fi operates on a particular channel, and your Wi-Fi device can switch channels with the access point automatically. It does it in the background. It says, hey, I can't hear you very well on channel. There's too many people on channel 1. Let's switch over to channel 2. Now, those channels overlap a little bit. So if you're on channel 2, you can actually hear a little bit of noise, a little bit of echo from channel 1, a little bit of echo from channel 3. But channels 1, 6, and 11, being 5 channels away, that's far enough away to where there is no chance of echo. If you get a hold of an Android and you are able to download, and you can buy used Androids for $10 or less on eBay, by the way. Get a hold of one, download Wi-Fi Analyzer. You will see how those parabolic curves are sometimes overlapping, sometimes not. And overlapping's okay. It's just that it reduces, just like I'm hearing other stuff in the room, or when you are at a baseball game or a football game, you're hearing echo, but you can still tell what's going on. The echo is not so bad that usually it's not so bad that you can't tell, you can't decipher the signal, but it is a little annoying. Does take away a little bit from the experience. And also keep in mind that when we draw these WAN drawings like this is purely conceptual and it's variable, because when I'm designing a LAN, I don't know what's in this space initially. Maybe there's nothing in that space. Maybe it's a warehouse. Maybe there's a bunch of pallet racks with a bunch of equipment, a bunch of metallic stuff in there. Maybe it's paper. Maybe I don't know what's in it. So sometimes we have to go back and modify these situations. Maybe I have to put another wireless access point between this 1 and this 11 here. Also, these are not perfect circles. You know, radio waves are not perfect. You know, one wireless access point might be able to communicate just great to the west for 100 feet, but to the east can only communicate 50 feet. And maybe that's because of the time of day or what's in the room, or other people using the wireless devices. So wireless is really a very imprecise science. So we can only make very general drawings about it. And it's one of the most misunderstood and most misused and improperly designed Wired is much easier to design. Wireless, there are people that specialize in just nothing but improving wireless communication. You could get a job just doing that. And that's not even a very exact science. Sometimes I make proposals to companies. We put in this new wireless stuff, and they still have problems. But they'll have problems one day, and then it's fine the next day. You worked in an open office environment, and you don't like it. Okay, ignore these pictures. This is the author of the book decided to put some of his pictures in there. This is consumer grade stuff where people are literally building racks in their homes. I don't know why this is still in this PowerPoint. There's a new PowerPoint and a new book coming out in November. I can't wait. Here's some other devices that are interconnecting devices in LANs. Load balancers. Load balancing devices are basically high-speed devices that can take traffic from one direction, let's say the internet, web pages, for web requests, for example, and pass those off to 2 or more devices behind the load balancer. If you have too much too much web traffic, too many web requests coming into your company, you can buy a second or third or fourth web server, share the data between them, buy a load balancer which has multiple ports on it, put it in front of the web servers, and all it does is it handles, okay, here's a web request from this IP address, I'll assign it to web server number 1 because he's not very busy. Or next one comes in, I'll assign that to web server number 2 and 3 and 4. So acting as literally as a switch. Virtualization. Virtualization is with respect to networks, and we'll talk about this, VLAN. I'm not sure if VLANs is in this chapter or not. It might be. Don't remember if VLANs is in this chapter. Virtual LANs. Security, we've already talked about the different security. And then SAN, a storage area network. A storage area network is designed, and this is usually a network that we don't put other nodes on. We don't put workstations on it. We put servers only on this network with special servers that have basically a whole bunch of hard drives in them. I've got a couple in the lab where it's a server that's about 4U high, loaded with 22 hard drives. And all its job is to provide storage space for other servers that log into it. On one of them, I've got 4 Ethernet connections going into it, all right directly into the servers they talk to. That's called a storage area network. It's a standalone, enclosed, closed circuit network, storage area network. Not to be confused with network attached storage, or NAS, which we'll learn about in a later class. They're similar, but SAN came before NAS. And if you go Google for NAS, by the way, you end up looking up a wrapper. So make sure if you ever Google any of these things, NAS, type in the word networking, NAS. Okay, improving performance on a LAN. How can we improve the throughput? The throughput is a relative measure of the data that's going across a LAN with respect to either a single user or maybe a single point in time for all users. Depending on the time of day for a business, sometimes the throughput can be bogged down at a certain time of day, like maybe 9 to 10 in the morning when a lot of people are checking emails and looking at stuff. Maybe it gets bogged down, and then at night perhaps there's very little throughput on a workstation LAN. We need to try to identify bottlenecks. So that is an official term, a bottleneck. Bottleneck is any restriction, any either forcefully imposed restriction, but not usually. Usually we refer to a bottleneck as a restriction that occurs because the throughput has increased to saturate, or it's higher than the physical capacity of the LAN that you're using. You're running on a gigabit LAN, for example, and you're putting through 1 gigabit per second constantly. That's obviously a bottleneck. So bottlenecks can occur at 3 different places on a network. Sometimes the bottleneck is the device itself. Perhaps the switch is just too slow. Sometimes I see this. Maybe the server's too slow. Maybe the network's fine, but the switch can't keep up with all the traffic, or the server can't keep up with the traffic. Many times, one of the first things I do, and one of the cheapest things I do when I go into a company situation and they've got a slowdown and they can't figure out where it is, I log into the server, and a lot of times I find, well, geez, man, your server's only got 4 gigs of RAM in it, or 8 gigs of RAM. Why is that? Well, that's all it was, that was the minimum requirement. And, this isn't a workstation. It's not like people are running a bunch of programs. And I say, yeah, but that server uses that RAM memory to buffer up accesses to its hard drive. And because hard drive access, that's the slowest thing you can do in a computer, is write data to a hard drive or read it off of a hard drive. That's why everybody's going to solid state drives. So one of the biggest bangs for the buck is put in more memory, put in more RAM. And that's fairly easy to do. It's a little bit disruptive. We have to take the server down most of the time, but usually I can take a server down, put RAM in, and bring it back up within 10 minutes. Sometimes it's the client devices. Sometimes the client devices need to be upgraded. Maybe we need to change one client who's a very high-end, high-usage client, like he's a CAD designer. We need to get him off Wi-Fi, if he's on Wi-Fi, and put him on a wired connection. Maybe even put him on a 10G wired connection. Maybe a fiber optic connection. Usually we don't do fiber optics to workstations. We can do 10G or even faster. You can actually do 40 gigabit per second on copper wires. It's not Ethernet. It's something similar to Ethernet. It's a big rectangular connector. Kind of looks like the DisplayPort connector on laptops. Could be the networking devices, as I mentioned, or it could be the circuits. Maybe all the computers are fast enough, all the workstations are fast enough, servers are fast enough, and it turns out, well, guess what? It's our Wi-Fi. It's just too slow. Sometimes we can increase the Wi-Fi, sometimes we can increase the numbers of circuits, but a lot of times if you're running on a gigabit network, the only way to really upgrade that circuit is you got to upgrade and replace all of the interconnecting hardware, and sometimes the wiring too. So in some cases, the way we solve a bottleneck, and usually on a circuit where we see the bottleneck occurring, is the wire that goes back to the server. The wiring that's going to your workstation in your office, not usually a bottleneck. And that's just like when you're driving into downtown Houston. There's not much traffic out in the country, but as soon as you get into downtown Houston, pretty much no matter what time of day it is, there's a bunch of traffic. That's because it's the central hub, the central location where people are needing to go. So what do we do to improve the circuit bottleneck? Add more freeways into downtown. In other words, some servers on some people's networks have 2, 4, 8 or more network connections directly into the servers. That's why I've got servers at the colo that have not 8 network cards, but multiple network cards and 8 ports. You can buy a network card that has 4 ports on it. What are we doing on time? Oh, I should be further along by now. Or the demand. Sometimes it's not the circuits, or sometimes we can't do anything about the circuits. We've maxed out. We've already put as many Ethernet cables in this server as we can physically fit. What can we do? If you exceed the physical limitations of your network, what can you do? You can reduce demand. So how do you reduce demand? And when I say demand, I'm talking about basically the demand from an end user, or the demand of data or information from a server. How do we reduce demand? Or can you think of what I might be talking about? Think about incentivizing or incentives. How does the electric company, because the electric company is a network, it's a WAN network, but it's a network. How do they attempt to level out demand? The electric company doesn't like, just like network managers, we don't like network traffic that goes up and down like that all the time. We don't like a nice, smooth, relatively smooth, steady network usage line. How does the electric company attempt to reduce demand through incentivization? Anybody ever watch those JEXA commercials, or where they're saying free nights and weekends, or free energy at the end of the month, or you get a credit, or there's a certain plan you can belong to where you get charged based on the time of day? That's how they're trying to do it. They literally incentivize you. We don't have that much control over electrical use at the company level. At the consumer level, that works, but at the company level, you can't just tell an employee, okay, turn your lights off for the next 15 minutes, or you can't use your computer for the next 30 minutes, please. Can't really do that with your employees. But what you can do is reduce the amount of data that needs to go back and forth to their workstations. So some data, particularly static data, can be stored on the workstations themselves. Let's say that there are training videos that you've got to watch. And this is true for all of you. You're going to go to work for somebody, and on day one or within the first week, they're going to sit you down to a computer, or they're going to tell you, okay, go log into the employee portal and watch these 7 hours of training videos. And I'm not talking about training on how to build the widgets that they build. I'm talking about the sexual harassment training, the COVID-19 training, the all these various trainings you have to go through because that company got sued at one point, or they have to maintain certain compliancy, like a HIPAA compliancy and or OSHA compliancy, and you're required. And I have to go through this training all the time, and I know some of you have done this before, and if you haven't, you will. You'll go through some ridiculous training where you'll be, it's kind of like, anybody ever take defensive driving because you got a ticket or because you wanted a reduction to your insurance? So you take, and so wouldn't you agree that 90% of it is ridiculous? It's like, well, yeah, duh, don't speed, don't run red lights, don't, you know. But you have to watch that stuff because the insurance industry said, okay, we'll give you a discount, but you've got to help us out by not causing so many car accidents. So there had to be some mechanism in place. So anyway, a lot of these training videos, they get created years ago and they're static. There's no reason to store training videos or help files or how-tos, things like that, on a company's dynamic server and download that every time to a workstation. If somebody says, well, I don't know how to do something, like press the help button here. You can store those locally on the workstations themselves, particularly videos, because videos are lots and lots of data. You need 7-8 megs per minute on most of it to get good video. Put that, pre-install those videos, pre-install those help files on the workstations. So if somebody needs to watch a video on how to do something, it's pulling from the local hard drive, not the network. That's one way to reduce demand. So move the files closer to the user. Okay? You understand what I'm saying there? Move the files closer to the user. Don't let them run over the network. Look at certain behaviors that are causing the spikes on your network, such as making backups. And don't make those backups in the middle of the daytime. Most companies schedule backups in between 3 and 6 a.m. when people are not using their network. Give me 1 second here. Okay, so reduce demand. These are important concepts. I don't, the PowerPoint doesn't really talk about them a lot, but I talk about them a lot because demand in particular. And this is why when we're designing networks, we always try to allot for and account for 2 to 3 times the demand that we think we're going to have, because something happens, COVID-19 happens, and holy crap, now I've got to watch. Now, in order to go back to the University of Houston, I think this is true for you students as well. For those of you that are re-entering University of Houston in the fall, you have to watch a 1-hour video on how to wear a mask and not cough on people and wash your hands and crap like that. Some of it might be helpful, but the point is that's going to increase network load. Already talked about this. Devices, upgrade the servers. Oh, RAID, redundant array of inexpensive disk. RAID is where we take, as I mentioned earlier, hard drives are the slowest thing in a computer for the most part. Spinning around a spinning drive, writing data to a hard drive is very slow. But if we can write data, the same data to 10 hard drives, 1 bit on drive 1, 1 bit on drive 2, 1 bit on drive 3, and stripe the data across multiple hard drives, we can get the data off and on those multiple drives faster. So you can go Google for RAID, and there's many different flavors of RAID, and I'll talk about RAID more when we get to the security chapter. Circuits, either increase the circuits if you can, but again, the circuits are very stair-step. 1 megabit, 10 megabit, 100 megabit, gigabit. Same with WANs. Or you add more circuits. Or you segment the network. That's another thing that we end up doing a lot of times. Let's say we have a department that has grown rather large. So engineering department, for example, and we've got X amount of clients and servers there. This box, it looks like a mainframe, supposed to represent the server. We've got all these clients accessing this server, and we figure out, well, the bottleneck is this switch here. The bottleneck is this gigabit networking here. That's slowing us down. What can we do to speed things up? Let us segment the network, add 2 switches, and this is made easier if we can functionally identify two different functional groups which might have been using that network. So let's pretend this. Let's pretend that we have we have one LAN in our office. Some people are engineers, some people are accountants, and each one of these functional groups needs to talk to different databases, needs to talk to different printers, needs to talk to different other people on the LANs. If we physically separate them, if we physically can separate those people into 2 different networks, add a router in the middle. So these are still 2 dumb switches. In other words, we reduce the number of nodes on a particular switch, and we use a router in the middle. So at layer 3, the router says, hey, the only time I'm ever going to get traffic here and pass traffic to the other side is if it's actually intended for me based on IP address. If it's broadcast traffic, like this guy needs to know if there's any printers on the local network, or this guy's requesting a DHCP address, or he's broadcasting out traffic. Broadcast traffic doesn't pass through routers. Broadcast traffic is ignored by routers. So broadcast traffic, which is about 3 to 5% of your LAN traffic, it's just background noise that's going on. It's like does anybody work for an office building where they're piping in music all the time and there's overhead music? It's always there. It's a little bit annoying. Sometimes it's supposed to be entertaining or keep you busy or whatever, but keep you working. But sometimes it's annoying and you want to turn it off. But it's there. It's excess, and maybe it's needed for a reason. Or maybe the broadcast traffic is saying like, okay, there's a fire, need to leave. There's important reasons why we have broadcast networks. So segmenting the network is literally bringing the network traffic up to layer 3 instead of layer 2. Programming a router. Now keep in mind, these 3 icons that you see right there, they may be one physical device. It may be a layer 3 switch. And I literally program that layer 3 switch and I say ports 1, 2, and 5 are going to be the engineering LAN, and ports 3, 6, and 9, and 12, that's going to be the finance LAN. Keep those 2 bits of broadcast traffic separate from each other. That's called segmenting a network. Reducing demand, moving client files to computer, encouraging the off-peak usage, and also this is another thing, and this is very effective for most companies. Consider blocking or throttling unnecessary network traffic. Now, we don't really do this much at U of H, but I guarantee you, if you go to work for some companies, particularly, let's say you go to work for a high school or a junior high, middle school. There are some websites and some types of traffic you are not going to be able to download or get access to. We intentionally throttle and block traffic to considered adult sites and music sites and gaming sites and streaming sites. And allow only traffic to go to out from our network to websites that are educational based. That's one way to reduce demand. We discovered, or not we, but the industry discovered that most students in using technology, they don't self-regulate. Actually, most employees don't do a good job of self-regulating. I'm sure everybody here has at one time or another watched a video while you're at work, or you watching a football game, or you're watching something, or you're using your network bandwidth for something that's not business related. Everybody's guilty of that. It's difficult not to do that. Sometimes there's not clear policies for that with your company, but it still causes a loss of bandwidth. So one way to get people to not do it, I mean, you could establish policies and say you can't watch ESPN.com while you're at work because it's just too hard on our bandwidth. We don't really care what you watch. Go grab a freaking TV set and stick it on your desk if you want, that with rabbit ears. Don't listen to music over our network. Bring an actual radio or use your cell phone. But people are going to do it anyway. So a lot of times companies put in more specialized, more expensive hardware that works at the IP layer that can literally block that kind of traffic. Okay, here's the end of chapter 7, and we'll just touch on chapter 8. I've spent a little longer than I wanted to. Implications for management. Enterprise LAN equipment is quickly becoming a commodity. In other words, most companies now of any size are realizing it's not good enough just to physically connect a LAN together and impose behavioral policy on our employees and our students and our customers and hope that they follow those policies. Even the most perfect of student, most perfect of customer, I promise I won't stream at work. I promise I'll just do my work and not use the network improperly. Even the most perfect of those is susceptible to a virus or social engineering or spyware that gets on their computer, and which also can cause a drain on the network. So enterprise equipment for control of the traffic and monitoring of the traffic, the network traffic, is essential. Is just pretty much damn near a requirement for networks of any size. SOHO, need you to know that term. It's actually a term that's rather passé now, but it stands for small office, home office. For everybody now who's working from home, we have a SOHO office, and that there are challenges and management differences with respect to SOHO offices. SOHO offices, primarily wireless. Speeds have increased, but things like internet access to communicate with your company's site, because you used to communicate with data at your company while you were at your company. Now you're communicating over the internet and your connection is asymmetrical. It means we have to consider, well, let's see, our demand is significantly increased going back into our company. What do we need to do with our data? Let's move the data closer to the users. Let's co-locate it in a data center, or let's locate it in the cloud with Amazon Web Services or Microsoft Office 365. Let's put it in the cloud and not run it here at our office anymore. And then the IoT, the Internet of Things, is significantly influencing the design of LANs, like 5G, for example. Within a couple of years, if not sooner, everything that you buy that has electricity running through it is going to have internet capability. Not just, and we're not going to really use that term anymore, a smart watch, a smart light bulb, a smart thermostat. Anything with electricity is going to have internet capability, because the advantages of doing that just far outweigh the disadvantages. And as I was showing you those Wyze cameras yesterday, it's super cheap. It's getting cheaper and cheaper and cheaper by the day to add Wi-Fi or add networking to the devices at your homes and in your businesses for purposes of control and monitoring. And I'm not talking about Big Brother control and monitoring. I'm just talking about management, even if it's self-management, even if it's you managing your own stuff. But We need new technology for that, new wireless frequency ranges, and that's what 5G supposedly is. 5G is not something that the government dreamed up to cause COVID-19 or fry your brain or spy on you. There's a lot of conspiracy theories about it. What were you saying? The what to, Franklin? You said what? What were you?
Having to watch that video for like an hour.
What's that about the video?
Yeah, you mentioned that we had to watch that video for like an hour before returning.
Oh, you said that a long time ago. Yeah. So yeah, I get. Is anybody in here gotten a job recently with a company, and on day one or the first few days or the first week, they said, okay, here's your mandatory employee personnel training packet and videos, and it's better. There's lots of reasons why we do that, by the way. Let me get into the next chapter, but lots of reasons why companies prefer to have you sit at home and watch a video, as opposed to the alternative to that is you take classes, you go to sensitivity training and ethnic diversity training and sexual harassment training, where it's face to face with a human. That's very expensive to do. As I'd said before, most expensive thing that any company can do is provide services to humans. Most expensive thing that a human can do is move around. If a network manager, and this is why management and connecting all these devices together, either wired or wirelessly, is going to save us money. If I, as a network manager, can look at every aspect of my network, my company's network, from my desktop here at home, I'm going to be much more efficient because I don't have to get up and walk 3 buildings over the campus to see is that UPS still functioning or whatever's going on, or take a plane ride somewhere to diagnose and fix something. Yeah, sometimes you have to go somewhere to fix things, but being proactive and managing things remotely is a huge money saver. We're going to come back to some more LAN-ish stuff when we get into the network security part 3 of the class, which we'll get into next week. Much more to it than just what I've talked about. Keep the concepts in mind that I spoke about yesterday and today with reducing demand, topology of a LAN. One 5074. Any questions so far, by the way? I'll pull up in my chat window. So we're not going to have class tomorrow because it's Saturday.
For the subnet assignment,
Yeah.
that second one, not the hard copy one, but the second one, we can turn on that one multiple times, right?
Yeah, and you can turn it in late if you really need to. Okay, I still allow people. It should still allow you to turn it in late. If you're up till midnight or whatever working on it, and you got to get some rest. Because either you put it off or you're having some issues with it, or I haven't answered an email from you yet. You can do it late. I'm not a huge stickler on the deadlines, even when it's not COVID-19. Oh, that's what I was trying to get to.
Professor, I have a question about the VPN too.
About the VPN assignment?
Yes, I sent you the screenshots like 5 days ago, but what else? Should I just wait for your reply?
Yeah, and again, as I've said for this class, you'll be fine on the VPN assignment because we don't need it for right now. What you need to concentrate on right now, what you need to worry about right now is the subnetting assignment. Okay, so don't stress over, well, I sent you an email 5 days ago, you haven't responded. That's because I'm kind of not ignoring, but I'm prioritizing the email I'm getting to answer, to move people along, and the VPN stuff is just not that important right now.
Makes sense.
Okay?
Yes.
That puts some people at ease. Don't stress over the VPN stuff. trying to save it. Okay, so chapter 8, backbone networks. We'll get, let's see, based on the time, we might get all the way through this. Let's see how we do. Get rid of chapter 7 here. Okay, so backbone network. I'm going to talk about the components of a backbone, architectures, how backbone topology essentially is laid out, best practices. So again, this is a fairly short chapter. Let's say we can knock it all out today, okay? So a backbone network, physically, very similar. In fact, a lot of times we use the same physical connection types. We use the same data link protocols. We use Ethernet a lot of times. And the traffic essentially looks the same. It's just a matter of the scope of the network. You can think of a backbone network as the interstate highway system like we have here in Houston. We have freeways and interstates, like 610 goes around the city, and then we've got I-10 and I-45 and I-69 and several smaller roads, and then we've got the individual roads within neighborhoods. Those would be like the lands. Backbone networks connect the lands together, all the smaller neighborhoods together into a network, basically. So think of the street network in Houston as a backbone network that connects all the lands together, each land being your neighborhood that you live in. And if you can understand that concept, it's a lot easier to understand what backbone networks are. The components of a backbone network: we use network cabling, and we use Wi-Fi as well. Excuse me, not Wi-Fi, scratch that out. In very rare cases do we use Wi-Fi. We might use wireless. We do use wireless in some backbone networks where the wire is difficult or impossible to get, like the moon. Eventually we'll have a backbone network from here to the moon, but it's certainly not going to be a wire 230,000 miles to the moon. It'd be too heavy. Layer 2 switches, we talked about the difference already between layer 2 and layer 3. I don't see too many layer 2 switches in backbone networks anymore. It's pretty much all layer 3 switches. But here we introduce the concept of the VLAN, or the virtual LAN. I just started talking about that in chapter 7. And we use VLANs on our backbone networks to segment out networks. So first of all, a definition of a router. Unlike a switch, a router is a network layer device. You have to program it. Sometimes we call them gateways if they also operate at layer 4 and layer 5. That's a requirement. If they don't operate at layer 4, if they're just lower end routers where they're only operating at the IP layer, then we don't call them a gateway, we just call them a router. They're not transparent. Messages are passed, specifically packets are passed, up to the network layer, including stripping off data link layer frames. So it uses data link layer frames, but there's a packet within that frame that it looks at. Whereas a switch simply passes frames and it doesn't care what's in the packet. It doesn't look at the packet, just looks at the frame. Routers are responsible for something called ARP, address resolution protocol. They read IP addresses and determine the best route. Many routers only have 2 ports on them. Like in the case of your home routers or your gateway devices that are at home, we can pretend for a moment that the gateway device is just a router. It's connecting your local network to another network. Now, routers can connect one local network to another local network, or one local network to a backbone network, or one local network to an internet connection. That's what you guys are familiar with at home, the LAN versus the WAN connection. That's not the only reason we use routers. We use routers to separate LANs. 2 LANs in the same building we wanted to functionally separate them and get them further physically away from each other. So we put a router between the two. Some routers, like I said, only have 2 ports. Sometimes those ports are dissimilar. One's an Ethernet port, one's a coax port. Some routers look just like switches, but they're typically one or more dissimilar physical or data link topologies going on in a router. It's talking to an Ethernet network as well as a coax network or a fiber network or or a wireless network even. It's talking to another dissimilar network. Routers require more processing than switches. So switches, as I said earlier, they do have processors and they do have memory, but not a big processor, not a lot of memory. It's a fairly simple bit of code that's in those switches, and that's why they're cheap. Routers have to have a lot of memory. Some routers have 4, 8, 12, 16 gigs of RAM in them if they're routing, if they have a lot of ports and they're routing a lot of traffic, especially if they're a core router that's routing traffic for like the entire University of Houston, for example. It's at the highest layer before the data goes off to the wild black internet, the wild blue internet, whatever. So they're usually in the processors. There's more powerful processors for routers. Okay, so backbone network layers, separate from the layers of the internet model, are these 3 conceptual layers: the access layer, the distribution layer, and the core layer. These are hierarchical layers. I'll show you a diagram in a minute. The access layer, this is the layer that's closest to you, the end user. You're not ever directly on a backbone typically. You're connected to a LAN, but then the LAN switch, which is in your on your floor somewhere in the main distribution facility for your department, it's connected to maybe another LAN switch or maybe a router, which that wiring or that first connection past your switch that you're physically connected to is called the access layer. You can think of it as you can access it. You can almost access it. You usually can't physically access the access layer. It's locked away in a closet. The distribution layer would be equivalent to the layer that connects the floors of a building together. So there might be 2 or more access layer backbone levels on one floor of a building because there's multiple departments in there, multiple LANs in there. The distribution layer connects all the layers of all the floors of a building together, and then the core layer connects that building to the next building. Between buildings here is let me skip ahead to I'll come back to that in a minute. Major types of backbone networks are based on the devices that are used. It might be a switched backbone, which is, again, that's usually only access layer. Routed backbone, where you literally have to program the managed switches, or layer 3. If they're layer 3 switches, that's basically a router. A layer 3 switch is a router. It doesn't have to be. Layer 3 switches you can buy and just throw in there and start using them, connect network cables to them, but they won't do anything special until you program them. It would be like using a car to sleep in. You know, it has many more capabilities, like it can drive you places, but yes, it can also be a bed if you need to sleep in it. And then we'll talk about virtual LANs in a minute, or VLANs we call them. Most common backbone network is using layer 2 switches. Oh, so sorry. I need more coffee. That's not necessarily true anymore. Most backbone networks are using layer 3 switches at every layer. Switches come in different form factors. FF, form factor. You have desktop style switches, which are the little 8 and 16 port switches. Most companies are using rack mounted switches. Rack mounted, and there is a specific size for rack mounting networking equipment. The IEEE and TIA came up with these sizes a long time ago. Rack mounted telco equipment is either 24 or 19 inches wide, the most common being 19 inches wide. We don't have much 24-inch hardware anymore. And the vertical measurement of these devices is called a U, a universal unit. 1 3/4 inches is a universal unit. So the smallest rack mount chassis, if you were to go Google for a 48 port, and almost all 48 port switches are going to be rack mount switches with little rack ears on the side of them. All of these things, some of them might be 2U, might be, but almost all of them are going to be 1U switches, and you'll see some little holes here and there's some rack ears that fit in there. We can smash 48 ports into 1 3/4 inches vertically and 19 inches horizontally. That's called a rack mountable unit. That's what you see in most main distribution facilities, in the closet of your businesses, if you were able to get into the wiring closet. And then you have also at the core layer, when we get higher up, you might see switches that are chassis based, which look like this, these monstrous things, where it might still be the same 19 inches wide, but these network ports here are basically cards that we slide into a specialized piece of hardware or a chassis. And the chassis itself, this thing has all of the cooling and backplane and processing and memory power on it. And these cards are simply adding the physical connectivity. And look how expensive these things are. They're kick-ass expensive, thousands of dollars. And this, a lot of times you buy one empty for thousands of dollars and then start populating it. Rack mount versus chassis versus desktop. Some of you might have a desktop switch. In fact, the easiest way to physically add more physical network connections at your home is to go down and buy a little 8-port desktop switch at Fry's or Office Depot for 25, 30 bucks. Take the Ethernet port cable that's coming out of your gateway, plug it into one port, any port of the switch usually, because they're all, at the layer 2, they're all the same. Usually we, as network managers, we designate either port 1 or the last port to be our inbound connection, and then you can connect your laptop and other devices to any of the other ports on the switch. I recommend, if you guys have the money to do this, if you have a few bucks laying around, purchase a little 4-port or 8-port switch, provided that you have a device that has a network connection on it. Now, if you have a newer laptop that doesn't have a network connection, you're going to have to buy like a USB to Ethernet adapter, which is going to be another 25 to 30 bucks. But it's always helpful to, where's my PowerPoint? It's always helpful to physically have your hands on some of these devices a lot of times to understand them better. There you go, I just lost that. MDF, main distribution facility. I think I've mentioned that before, but this is basically a centrally located closet. That's not a very good one, but that's an example of what you might see inside a closet at U of H or at your company, somewhere on the floor of your building. Now, this is terrible cable management. If I were to see something like that, I would scream. But basically, what we're seeing here is all of this stuff at the top here. These are called patch panels. They're usually at the top. Notice that this is a 2-port rack. It's called a telco rack. It's 19 inches wide, but it's only 2 post. I said 2-port. I meant 2 post. Then they have data cabinets, which are 4 post, or they're more of a full cabinet, which we put servers in. These telco racks typically don't have servers in them. They have interconnecting devices. So at the top of most of these racks, we have what's called patch panels. We bring the cables in from the various offices, from the various physical waypoints, punch them down, we call it punching them down, into the back of these things called patch panels. In the interest of time, I'm not going to go jumping around and find a patch panel for you, but go Google for patch panel, 48 port. Go bring one up on your screen, take a look at it. They come in Cat 5 flavors, Cat 6 flavors. It's a physical layer device. There's no electricity that a patch panel generates or needs. Electricity's passing through it, but it's a physical connecting point. That is important to have in networking. It's an important physical need to have a patch panel to terminate the cabling coming from the other offices, because many times when this stuff gets installed, this equipment doesn't exist yet. It hasn't been purchased yet. We've hired a cabling company to come into our building, run a bunch of cables, because again, I said, do the cabling before the building's done being built, before the walls are up. They got to terminate them into something. Otherwise, they're just leaving the cables hanging out in that room. So typically companies provide the telco rack and the patch panels first. And then when you occupy the building and begin to install your network infrastructure and you install your switches, each one of these is a switch. There's 1, 2, 3, 4 switches in this rack, all going to different ports. This might be, floor 1, that might be floor 2. They're all terminating into this 5th switch, which has many fewer ports, but this is a distribution layer switch. These are all access layer switches. They're literally probably connected to printers and workstations through these patch panels. So we terminate these patch panels with cables we call patch cables. That makes sense, right? Patch cables. You can go Google for patch cable. They usually come in 3 feet, 7 feet, 10 feet, 15 feet, 25 feet patch cable. So the first backbone. So here what we're saying, these patch cables, this is basically your first layer of, this is LAN. This is not even the backbone network yet. These wires, if you can see them right there, these are your first backbone network. That's your access layer. These LAN switches are feeding into this presumably higher speed layer 3 switch. It has fewer ports on it. They're probably higher speed ports. And they are connected like this. Here's the conceptual draw.io diagram of that switched backbone. So each LAN is terminating into one, possibly more than one of those switches, and then each one of these switches is got its own patch cable terminating into one port in this layer 3 rack mount switch, or maybe even a chassis switch, and then there will be, if you're connected to the internet, one additional, whoops, I didn't mean to do that, sorry. One additional connection right here. It's kind of hard to see. There's a wire over here on the right, which is that's probably a fiber optic connection going off outside the building, going off to this piece of equipment going outside the building. This here is acting as a router. I guarantee you this one's programmed as a router. What I see sometimes is I see switches installed, and this is a bad practice. I see this switch daisy chain to this one, then to this one, then to this one, then to this one. We never do that. You can do that. It will physically work, but you don't ever want to run switch traffic from one LAN through other LAN's switch traffic. Otherwise, you've just created one gigantic LAN. You need to not daisy chain them. In other words, this right here, I know it doesn't look like it, but that's a star topology. Backbone networks also appreciate a star topology. Wouldn't you agree that's a star topology? These switches don't have to be literally right underneath that backbone switch. They could be in different physical locations in the building out in a star pattern. But as long as there's a cable that goes from this LAN switch directly back to the access layer or the distribution layer switch or router, we call that a home run. Then there are only two physical hops between you on your LAN here. So you're sitting out on your LAN. There's one physical hop to get you onto the switch that you're attached to, and then one more physical hop to get you into the access layer or distribution layer backbone switch. Okay? That's conceptually the right way to do it. So here's another scope drawing here. Each one of these might be a computer on a LAN. Each one of these switches is a LAN switch, and we are connecting to presumably a higher speed switch, possibly these connections, they might even be fiber connections, not usually at the access layer, but these blue lines right here at the bottom, these are your access layer connections. These are all LAN connections based on these icons, assuming these are all desktop computers. Would you agree that's a star topology? I know it's not drawn like a true star, you know, in all directions, but that is a star topology. Everybody is radiating out from this central core device. That's, by the way, that's why we call it the core layer, as it gets deeper, deeper, deeper into our network, as you get into the core of the network. The core is the furthest away from you, by the way. When we talk about different levels, the access layer is closest to you. The distribution layer is the next layer that connects the various access layers together within a building. And then the core layer would be like at University of Houston, for example, we have a backbone that connects all the buildings together, and they all terminate at the PGH building. Do you guys know where the PGH building is at U of H? It's approximately in the center of campus. It's the building where you may have taken some math classes at if you are a U of H person. And the reason that it all terminates to the PGH building is because that made the most sense. It's literally in the middle of campus. So that truly is, if we were to draw the U of H network, it looks more like a true star topology, more like that. So they all terminate into the PGH building, and then the PGH building has one or two very high-speed fiber connections that go over to the computing center on Elgin over there next to Channel 8, where all of our internet connections come in. They don't come into the PGH building. They could, but we had them come in over at the computing center because we have better physical control over there. We don't have very good physical control in the PGH building. We got students and faculty coming in and out all the time. We don't. We want to protect our core. So we put the core as far away from our end users, our destructive end users, as possible. End users are destructive, whether they intend to be or not. Now, why do I say that's bad? Patch cabling, look how that's all just hanging down. Most network racks at professional sites, they will use cable management systems where these cables, patch cables, are literally passing through channels, which help route them, because these cables hanging like this, that puts a strain on these connectors. Cables can get heavy. And if you look at like some of the pictures I posted on my Facebook page with respect to network, I do want to show you a couple of these pictures just because it's amusing to me and it's interesting. Nice MDF. Let's see if I can find a nice MDF. No, not medium density. Nice network MDF. Let me see if I can find a nice picture of a good looking MDF. Okay, that one's fairly nice. There's still a lot of cable hanging. That one's super, oh my God, look how clean that one is. That's beautiful. Cable guys like me, we get I'm not gonna get, I was gonna say something inappropriate. We get excited when we see cabling that looks like that, because management wise, that's really easy to manage. If we have a physical problem, cable is broken or malfunctioning, or we need to track something down, it's really easy to follow cabling like that, as opposed to not a good example. I think I saw one here on the screen. Oh yeah, there's a bad example. That's bad. That's probably the before picture, and that's probably the after picture when they installed the cable management systems. So this ugly network MDF. Let's see if we can find some images of that. We can literally find, yeah, nightmare stuff. That's the AT&T does that a lot. That stuff might be functional, but it's pretty yucky. Like, you know, no, that's even not that bad either. That's pretty. We call it cable spaghetti. Yeah. So when network managers see this, that's what we look like. We're like, holy crap, there's no way. You want me to find cable number coming from your office plugged in somewhere, especially if those cables are not marked. That's one of my favorite pictures there. Yeah, that's me trying to find something. So cable management, in terms of network management, you guys probably didn't realize this, but you might be that guy sometimes. He's probably not a technician. He's probably there trying to fix something because the technician can't be found. But yeah. Also, that amount of cable, a network cable, one single Ethernet cable doesn't weigh much, but you put 1,000 Ethernet cable, and I've seen this before. I've seen cable messes like this, and I've heard reports of racks falling over because there was so much nasty cable on there that the cable became 1,000 pounds and pulled the racks down, destroyed the rack. So it can get crazy. That's part of management. Physical management is part of management, just like anything else, just like data link management and IP management. So as I said here, connecting the floors together, these connections between the floors, that is the distribution layer. It's the layer 2, the next layer, not layer 2 of the internet model, but our next hierarchical layer up. And then finally, we have a core layer connection to our campus backbone, which is typically needing to be a much higher speed network, because this freeway lane here, again, these lanes, these freeway lanes, is still only a 2-lane freeway. Okay, but that means the speed limit on this freeway, the vehicles that drive on this freeway have to be like Ferraris or Lamborghini or super rocket ships. And there has to be an unlimited speed limit or a much higher speed limit on these networks. So the network that goes from the cabling that goes from the PGH building to the core network over on Elgin, it's all fiber optic and super high speed. We're talking 100 gigabit per second, 600 gigabit per second, much much faster connection. Okay, routed backbone versus a switched backbone for LAN segmentation. I'm gonna speed up a little bit here. Here's a little bit better picture of the entire hierarchy of you in relation to the internet. Here's you, and it looks like you are talking directly to the internet, but your traffic is passing through a LAN switch, which then passes through an access and distribution layer switch, which then goes to a core layer router, which then goes back to the building on Elgin there, and then ultimately there's a connection to the internet. All of this information, or what's common with all of this, is that organizations, just like LANs, most organizations own their own LANs and own their own backbone networks. Past here, when we start talking about WANs in the next chapter, we don't typically own that. We do own all of this stuff. And the layer 2, the frames, the layer 2 protocols may be different, but usually from all the way to here to all the way here, it's usually Ethernet, from there to there. It's not the same frames. The frames get regenerated every time it hits a physical piece of equipment into a new frame. But this might be a different type of protocol. It may not be layer 2. It might be just layer 3, just IP layer. So it's not the same kind of frame or network traffic passing into the internet. Usually it's either more or sometimes less efficient, like in the case of DOCSIS or networking that you use on WANs. It's less efficient on purpose because past my core router here, I'm on a shared network with the rest of the world, and I have to be nice to the rest of the world. I don't have any control of the data in the rest of the world, but I can control my traffic inside my own network. Okay, VLAN. I'll end the class with VLANs. It's almost 4 o'clock, and I want everybody to have a nice weekend and get everything done that you can get done. VLANs. VLANs give you some flexibility. So let me give you a scenario here. I'm going to skip ahead here. Here's a scenario. Simple 8-port switch, okay? Let's say we've got, each one of these is a PC that's physically wired in an office. Maybe not a PC, but maybe there's a connection. Physically, this port 1 goes to office, 201, port 2 goes to office 202, whatever. They're all on the same floor. Let's say an employee moves, an employee that was in a functional office or a functional group moves offices. He's no longer right next door to all the other finance guys. He gets to move upstairs, or he gets to move somewhere else. Well, if we had a situation where we want to keep them segregated by LAN, and we had this situation here. So the guy moves. Let's say that this is the switch here for the finance department, and then these other switches are for engineering and other departments. If he moves from this patch panel, assuming it's terminating here, and he's physically now is going to move to an office which is terminating on this patch panel or this patch panel, he's no longer on that switch anymore, physically. So what do I have to do as a network manager? I would have to go to the closet, find his patch cable, find his port number, disconnect that cable from the switch that it's terminating into, and replug it back down into the finance switch, back into port 1. In other words, I have to make a physical connection change to put him back on the finance LAN simply because he's moved. Now, what did I say was one of the most expensive things a network manager can do? Is to get up out of his chair. The cheapest thing and the thing that you want your network managers to do, because you're paying them a lot of money, is you want them to sit their ass down and stay there. Because anytime I'm having to move and physically touch stuff, there's transport time. That took me time to do that. If I can simply push a button on a keyboard, I didn't have to get up, and I could do it easily, and I can even automate it, do it via automation, or do it remotely. So in the case of a VLAN, first of all, we have to use not just managed, but layer 3 switches with VLAN capability. And most managed switches that you buy do have VLAN capabilities. It's a subflavor of Ethernet called 802.1q, or there's different flavors of VLANs as well. So we can physically segregate. We can log into our switch, our layer 3 switch, and say, okay, ports number 1, 2, 4, and 7 in this example are going to belong to this thing we call VLAN 10, or we can call it the finance VLAN if we want. And the remaining ports 3, 5, 6, and 8 are VLAN 20, or some other VLAN, engineering VLAN. If the guy that was in Office 2 moves, or we put somebody else into Office 2, and he's not part of VLAN 10, he's not part of finance. He doesn't need access to finance's printers or broadcast traffic. All I have to do, if this was a managed switch, is log into it and literally program port 2 and say, port 2 no longer belongs to VLAN 10. Port 2 belongs to VLAN 20. I do this all the time. It's a huge time saver. So when I'm installing networks, as long as I put in managed switches, it doesn't really matter. In this case, if all of these switches are VLAN capable switches, and the cool thing about most VLAN protocols is they operate not just within a switch. You can send a frame out from one switch to another as long as all these switches are VLAN capable and they speak VLAN language. You can create a VLAN which lives across multiple switches. So what I try to do is buy switches that have VLAN capability, plug these patch cables indiscriminately into any port. I don't care what port I plug them into. Or maybe I do care initially, but I can plug them into any port I want to. As long as I program on the web GUI for that switch or for those switches. A lot of times with these managed switches, you have a web GUI where one manages all of the others. And I can say, well, port 1 on switch 1 and port 4 on switch 2 and port 7 on switch 3 and port 9 on switch 4. That's all VLAN 1, and then go program all the others for VLAN 2, 3, and 4, and so forth. The 802.1q VLAN capability allows you 4,096, and that's because it's 2 to the, what is that, 2 to the 10th power? Let's see, 256, 512, 1024, 2040. No, it's 2 to the 15th power, 4,090. They allow you 4,096 different VLANs. That should be plenty. Most companies don't have 4,096 VLANs. Even large organizations that might have 100 VLANs or 50 VLANs, but that is plenty. Your frames that come out of the switches are tagged. It's called VLAN tagging. And you can set up VLANs based on port number, or you can actually, when you do use VLAN tagging, you can actually tell applications from somebody's computer to be tagged based on what the application is. For example, let's say I'm running, and this will be the last thing I say today. Let's say I'm running a voice over IP or a Zoom application like I'm doing right now, and it's using a certain TCP port. I can tag my Zoom frames as being and belonging on a different VLAN network as my normal frames, my email and my web traffic frames. And what that does is that gives me control at this level, at the MDF level, to be able to pass that traffic, not based on physical connection, but actually based on what the application was that generated it. Because maybe if it's video traffic, maybe I want to send that through some higher speed connection, like a fiber connection. But if it's web traffic, I can send it through a copper connection, a different connection on the internet. So VLAN tagging, the only other way to be a member of multiple LANs with a workstation is to put multiple LAN cards and physically connect them together. But with VLAN tagging, I can have one network card or one network port on my computer, one piece of cable coming out of it, hitting this MDF, and let the MDF figure out which application generated that traffic. Oh, it's tagged. This is supposed to live on VLAN 10, which is my VoIP LAN. Let me go route that in some different way, or let me give it priority. That's really what VLAN tagging is for, is to prioritize traffic. So in case, and this has happened to some people, right now we're having a Zoom meeting. If you started downloading Windows updates right now, it's possible, in fact, it's probable that my Zoom connection will start getting choppy. Or if you start watching Netflix or something else in another window, my Zoom connection will get choppy. With VLAN prioritization, and usually end users don't have control of this, network managers do, we can prioritize voice and video traffic and say, that is VLAN number 1000. That has the highest priority. Please pay less attention to him downloading FTP files and email. Pay more attention to these video packets and deal with them first, or video frames, and deal with them first. Okay, so VLAN, I want you to Google for that, because the book is not real good about this, but make sure you understand the concept of VLAN tagging and specifically what it's for, and it's to help to prioritize traffic, to keep choppiness from happening. Otherwise, if you were using a headphone and Skype, your Skype communication can get choppy if your computer starts doing an update in the background. That's what VLAN tagging helps. Let me just see real quick how much more there is to this chapter. There's not a whole lot more. It's VLAN tagging. We were just about there. So what we'll do is we'll pick up the last two frames of chapter 8 on Monday, and then we'll get right into chapter 9. So I told you chapter 8 was pretty short. All right, so thanks for waiting on me and going all the way to 4 o'clock, because it's 4 o'clock now. You guys have a good weekend. Make sure that you get the assignments done to the best of your ability. And like I said, if you're stuck somewhere on, I couldn't go any further on VPN because I couldn't get it to work, or I couldn't use NAT translation to get into the EI lab. You can do all the other stuff. You can watch the video that you were supposed to watch for the cabling. You can do the subnetting assignment, and you can start preparing for exam 2, which is probably going to be made available Monday or Tuesday. It's going to come up pretty quick here. So, and I will diligently continue to read and answer the emails over the next couple of days here. If you end up turning in something late on Sunday or even Monday, don't stress. Turn it in. Don't not turn it in. Do it anyway, even if it's not perfect or not close. And as I said before, you have multiple attempts. I'm pretty sure I made them unlimited. I'd rather not grade 10 versions of something. You know, give me your best 3 shots, okay? Any questions? Not seeing anything in chat. Don't hear anything. So for those of you that are still here, thank you for bearing with me on a little bit extended of this class. And I'll post this video just as soon as it converts onto YouTube, and I'll send you guys out the link for that in case you need to go back and look at this for purposes of exam 2, or in case you're a student and you're not here, because I only see about 8 students here right now.